Hey there, just helping out with our Unit 5 test and your preparations for it. So you have your practice for our Unit 5 test. If not, go get one right now from the pickup station. We're going to make a video, one for each page. So feel free to speed up or slow down. I'm going to do this pretty quickly. So if you need to hear some of it slower, rewind it. If you need to hear some of it faster, speed it up. You have that power. All right, we're going to write a function to model each situation. So everything is always thinking about what do we start with? What are we multiplying by? And then raising it up to some amount of time. Okay, so our exponent, we have to have exponentials, we have to have an exponent. Okay, when we're writing these functions, if our time is unknown, that's most likely to be our exponent. Our x is probably going to be time, our exponent going on there. So population of bacteria doubles. That's telling me the multiplier. There were 11,000 bacteria to begin with. So we start with 11,000 bacteria, and it is doubling every single week. So we're going to raise it up to the x power. A $7,000 car, there's our starting amount. It is losing 2/5 of its value. Please remember that that multiplier always has to be how much we are keeping. Okay, it's the keeper amount. So if I'm losing 2/5, this really means that I'm keeping 3/5. Okay, if I lose 2/5 away, that's 101 minus 2/5, which gives me 3/5 left. So that's how much we are keeping, 3/5. A YouTube video has 2,500 views. It triples each week. That means it's getting 3 times bigger each week that we have it up on YouTube. A person takes 750 grams of Tylenol. That's a starting amount. The medicine in their body decreases by 1/4 each hour. That means it's losing 1/4. Remember, how much is it keeping? If it decreases by 1/4, it keeps 3 out of 4. If it loses 1 out of 4, it keeps 3 out of 4. $1,000 phone loses 4/7 of its value. If it loses 4/7, means that it's keeping 3/7 of its value. So $1,000 phone, keeping 3/7 every year. Each contestant starts with 15 points, and the available points triples each round. 15. A person takes 200 milligrams of medicine. The medicine in their body decreases by 2/3. It loses 2/3. It keeps 1/3. So that 200 milligrams, 1/3 every single hour. Spotify started with 150 artists. Their plan is to double the number each month. 150, doubling, and then they'll double again and double again and double again. So that repeated multiplication is how we use an exponent. The number of bacteria in a sample quadruples. That's 4 times each day. So 1,000 bacteria getting 4 times bigger every single day. And a music video on YouTube has 200 views. It multiplies by 1.5 each day. Just going to interpret real quick. Remember, this keeps the 100% that it reached the first time, and it's going to add another 50% each day. So just interpreting that decimal into a percentage. 200 views, multiplies by 1.5, raise it up to x. The value of a car over x years is represented by this function. That 27,000 And the 2/3, I need to know what they tell us about this value of the car over time. All right, so this function, I'm identifying a couple things. First is that 27,000, that's multiplying out front. That's our starting amount. So the car starts at a value of 27,000. That 2/3 means that it keeps 2/3 of its value every single year. Yeah, over X years. I was looking for that word right there to see how often it was doing it. So it keeps 2/3 of its value. We could also write that it loses 1/3 of its value. If it keeps 2/3, we could also say that it loses 1/3 of its value each year. We have an equation, a different one. This one is also shrinking, I can tell, because that multiplier is less than 1. So if it's less than 1, it's going to be going downward. So when we consider this equation, it's the amount of medicine in a person's body over a certain number of hours. The 350 tells us how much they took as a starting dose. So our starting dose of medicine is 350 milligrams. The 1/4 tells me how much it keeps. So this must be a really fast working medicine because 3/4 of it is being absorbed into the body each hour. So the 1/4 tells us that it keeps 1/4 of the amount each hour. And another equation, this one is multiplying by 3, so it's more than 1. That means it's a growing function. This might be some stuff that I would put on an index card, just giving you a little idea there. Our keeper amount for our multiplier, if that is greater than 1, then we have a growing graph. If it is less than 1, then we have a shrinking graph, okay? So thinking about what that looks like as far as whether things are growing or shrinking, that also helps us when we get to the percentages. We'll just keep that in mind. This is the amount of germs on a person's hand over a certain number of hours without washing their hands. Oh, this is gross. That means a person starts with 40,000 germs when we start timing. The 3 tells me that the amount of germs triples. So germs, oof, forgot my M, sorry. Germs triple every hour. All right. Let's keep on going. We have 2 more questions here on this front side, and one of them's well, they're both multi-part. It asks us in number 14 to start filling in the following tables. So if this tells us our starting amount, remember that's our 0 amount. If we give it no time, that's our starting amount. So that beginning number is going to go in our 0 time. And then as I move forward in time, it looks like this one is tripling. So in 1 hour or one of whatever, it's going to triple. So it'll go from 1,000 to 3,000. So tripling. And then doing that again times 3, 3,000 times 3 is 9,000. Now, if I multiply by 3 to go forward in time, I'm going to divide by 3 to go backward in time. You can also use the equation and just type these things into your calculator. So I just want to bring that up there too. That we could do 1,000 times 3, and remember the little caret button, wherever that caret button is going to raise it up to an exponent. And we could raise it up to the second power. It confirms that it's 9,000. And if I go backward a day, instead of multiplying by 3, I'm going to do 1,000 divided by 3. Or again, I could type that into a calculator, raise it up to the -1 power. Okay, so a -1 is going to tell us the same thing. Write that again, type it in. What about going 2 days or years or whatever before? It would be 1, 1, 1, because we are dividing by 3. Our next one starts at 2, so 0, 2 is going to be an ordered pair on this table. It is multiplying by 4. So go to 8. 8 times 4 is 32. I multiplied by 4 to move forward in time. I'm going to divide by 4 to move backward in time. 2 divided by 4 is 0.5. I'm going to try that again on a calculator. 2 divided by 4 is 0.5. Divided by 4 again, 0.125. Or again, just type it on into the calculator. Okay, so this next one I'm going to just do on the calculator, typing it in. 3 times 10 raised up to the -2 power, 0.03. 3 times 10 raised up to the -1 power, 0.3. 3 times 10 raised up to the 0 power, 3. Are you noticing a pattern? 3 times 10 raised up to the first power, and 300 because it's multiplying by 10 each time. Growing, 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 shrinking, less than 1. Shrinking graph. Starts at 200, multiplies by half each time. So half of 200 is 100, half of 100 is 50. If going this way, I am multiplying by 1/2. Here I would divide by 1/2, which is the same as multiplying by 2. All right, so this way we were dividing by 2. Maybe let's think of it that way better. Dividing by 2 each time. Let's multiply by 2 to go the other way. Again, we can just use the calculator. Point 1 repeating. Point 3 repeating. Oops. However you choose to do it, we can see which ones are growing and which ones are shrinking. And the last part here on page 1. Given each set of 2 exponential functions, circle the one that increases more quickly. So I am just going to be looking at what is in parentheses. What is that factor multiplier? Okay, I'm looking for the biggest number here. The biggest number is increasing most quickly. Sorry about that. All right, so this one is doubling, this one is tripling. Tripling is faster. Let's see, 5 divided by 2, 2.5. This one's getting 4 times bigger. 4 is bigger than 2.5. Ooh, 5 over 3 and 4 over 3. Well, 5/3 is 1.6 repeating. 4 divided by 3 is 1.3 repeating. Our f of x function, the first one is going to be bigger. So I'm just going to keep on doing that. Whichever one is the biggest number is going faster here. Okay. Definitely 5 times is bigger than 1.5. 2 is bigger than 1.2. 3 is bigger than 1.5. So we can see which one's growing fastest. There's page 1. Keep it going.